Hello students, in today's discussion, let us discuss about Unit 2 of course Wireless Networks 19 EC 507. So under Unit 2, we focus on mobile network layers. So the course outcome for Unit 2 is to compare different protocols used in network layers. So whenever we talk about networking or network layers, we would initially begin with the idea of IP, Internet Protocol, right? So in today's session, we'll discuss about the Internet Protocol layer, the mobile IP, also the architecture of mobile IPv6. So earlier we had IPv4, later on due to the larger address space, the need for larger address space led to the discovery of the next version, IPv6. Yes, let us move on. So what is this mobile IP? The mobile IP is a communication protocol which is defined by the Internet Protocol Standard, and this helps the users to move from one network to another with the same IP address. So this IP address is a unique address defined by the standard IP standard, and they ensure that the communication will continue even when the user sessions are dropped, right? So let us quickly go through the simple mobile IP terminologies which each and every one of us must know. So the first one is the mobile node, MN. Mobile node, this is a handheld communication device, or it is a mobile terminal, or in fact the client that the user carries. Okay. Then comes the home network. Home network is a network to which the mobile node or the client normally belongs to. Okay. So only the home network assigns the IP address to the mobile node. So we say that it is a network to which the mobile node originally belongs to as per its assigned IP address. And then you have the home agent HA, which is acting like a router in home network to which the mobile node was originally connected. And then we have the foreign network, which is the current network to which the mobile node is visiting. So normally, not always our mobile node will remain in the same home network, right? So depending upon the requirements, the mobile node tends to move from the home network to a foreign network. So foreign network is the network to which the mobile node is currently attached to. Foreign agent. So foreign agent is similar to the home agent. So this is a router once again, which is present in a foreign network to which the mobile node is currently connected. The packets from the home agent are sent to the foreign agent, which delivers them to the mobile node. Next comes the terminology correspondent node, CN. CN stands for correspondent node. So this is a device on the internet communicating to the mobile node. And then you have COA, care of address, and this is actually the temporary address that is used by our mobile node when it is moving away from the home network, right? Then we also have a foreign agent COA, and this could be located at the foreign agent whenever our mobile node is moving away from the home network. And what is this CO located COA, right? So COA is located if the mobile node is temporarily acquiring an additional IP address which is acting as the care of address. This address is actually topologically correct and the tunnel endpoint is at the mobile node. So these are all the few terminologies which we must know whenever we design any mobile IP network. So now let us move on to the mobile IP architecture. So what is the function of this mobile IP architecture? Hope everybody can look at the screen. So we have a mobile node, a correspondent node, a home network, as well as a foreign network, or within which you have a foreign agent also. And there is a tunnel drawn in between the foreign agent and the home agent for communicating, right? So normally the correspondent node sends the data to the mobile node, and these data, right, the data packets contain the correspondent node's address, which is normally referred to as the source address, along with the home address, or yes, along with the home address as well as the destination address. Okay, but now as the mobile node starts moving, it is no longer present in the home network, so it gradually moves to a foreign network, and so the foreign agent sends the care of address to the home agent, to which all the packets should be sent. So this is the main role of the foreign agent. So now we try to establish a tunnel between the home agent and the foreign agent, and this process of establishing tunnel to communicate the data between the home agent and the foreign agent is known as tunneling process. Okay, so tunneling helps us to establish a virtual pipe for the packets available between a tunnel entry and an endpoint. So let us again recollect. So tunneling is actually a process of sending, or it is a virtual pipe mainly used for sending a packet via a tunnel-like structure, and this is achieved by a mechanism called encapsulation. So we try to encapsulate the data and then communicate via a virtual pipe from the home agent to the foreign agent. The home agent actually encapsulates the data packets into a new packets in which the source address is the home address and the destination address is the care of address. Okay, and the foreign agent which is present on the other side of the tunnel actually receives all these data packets through the tunnel. They try to decapsulate them and sends them to the mobile node. Yes, so the mobile node now collects the data from the foreign agent, and in response to the data packets received, it sends a reply message to the foreign agent. Yes, the foreign agent actually, whenever we try to define this foreign network, the role of foreign agent is like it directly sends the reply to the correspondent node. So as the mobile node retrieves back the data, it also receives a reply in response to the foreign agent, and the foreign agent directly sends the reply to the correspondent node. So this is the function of the mobile IP architecture. So we have defined the role of a mobile node, home network, foreign network, the correspondent node, as well as the process of tunneling. Yes. So these are all the key steps in mobile IP. So we have agent discovery, agent registration, the tunneling mechanism, as well as the route optimization. So this route optimization actually adds a conceptual data structure binding updates to the correspondent node. So this defines the effective route for communicating between the home and the foreign agent. Yes. So now let us step on to the next standard, which is mobile IPv6 Internet Protocol version 6. So can we just recollect the basic features of IPv6 quickly? Yes. So the main features of IPv6. So whenever we think about IPv6, the first key point is the larger addressing space. Then we have a simplified header version. Then end-to-end connectivity, stronger security, where we implement a security process called IPsec, a faster routing or faster forwarding mechanism, Then one of the most important key functionality is the auto configuration mechanism here. So these are all the main features of IPv6 over IPv4. And now let us quickly go through the concept behind mobile IPv6. So what is this mobile IPv6? So this is actually defined by a standard called IETF. Hope everybody knows what is this IETF, Internet Engineering Task Force. So they were the one who proposed the mobile IP concept, and later on it led to the discovery of mobile IPv6. Actually, mobile IP allows TCP or UDP to continue even if the underlying hosts are roaming and changing their IP addresses. Whereas when we look at the architecture of mobile IPv6, here each mobile host is usually connected to a network called the home network, where the mobile node is registered with the router called the home agent, as how we saw in the previous slide. So now we try to identify every mobile node by its home address regardless of its current point of attachment to the internet. Correct? Whenever they are away from the home, what happens? This mobile node is connected to a foreign network where it is allotted with a special type of address called care of address. But still, what happens? What is the main issue here? In mobile IP, we include a mode of operation which is allowing the mobile node and the correspondent node to exchange packets directly, bypassing the home agent completely after the initial setup phase. So only for the initial handshake procedure or only during the setup phase, we have the home agent to take the role between the mobile node and the correspondent node. So once it is established, the mode of communication will be directly done between the mobile node and the correspondent node. And this mode of operation is normally known as the route optimization. Okay, so whenever we go for route optimization in MIPv6, which is mobile IPv6, here the mobile node tries to send the binding update message to the correspondent node, informing the newly acquired care of address along with its home address. Yes, I'm sorry. Actually, this is the routing architecture of mobile IPv6, which we are discussing right now. So you can locate the home agent as well as the correspondent node, mobile node, the forward agent, where we have a tunnel in between, right? Yes, so let us continue. The correspondent node, which is actually a IPv6 node, catches a binding message of the mobile node's home address along with the care of address, and it tries to send any packets destined for the mobile node directly to it, right? So what we infer from this architecture, what do we learn here? So with the principle of mobile IP, any mobile node may change their point of attachment to the internet without changing their home IP address. So this allows them to maintain transport and higher layer connections while roaming. So this is one of the main significant advantage of mobile IPv6 route optimization process. So with this, let us wind up the discussion on mobile IPv6, and in the next class, we'll look about the other network layer protocols. Thank you.